All right, well, welcome to this lesson on combinations. So we have already looked at permutations and now we're going to look at combinations. So a combination is an arrangement of objects where the order does not matter. So we looked at permutations and this is where order does matter. So if I look at this example where if I have a group of 10 people and I need a committee of 3 to decorate for the dance, it doesn't matter what order they are chosen in. So this is a combination question. If I wanted to choose a vice president, a secretary, and a treasurer, like where they have specific jobs, then order would matter. So that would be a permutation question. So when you're doing these questions, you always want to begin by asking yourself if order matters or not. So does it matter what order the items come to you in? And if it doesn't matter, it's a combination question. So there is a formula, just like there was a permutation formula, there's a combination formula. However, we're just going to use the combination button on your calculator. You'll find it near your permutation button, most likely, but it will look like NCR instead of NPR. Okay, once you've got that button, let's take a look at some examples. So it says you enter a fun golf tournament in which you are only allowed to take 3 clubs from your bag. If your bag contains 11 clubs, how many different sets of 3 could you choose? So it doesn't matter what order you pick them out of your bag in, like you just need 3 clubs in the end. So that is a combination question. So we need to go 11C3, which when I put that on my calculator comes out to be 165. So just to point out, we can't use the spaces here because the spaces are specific for a permutation where order matters, okay? It doesn't matter what order I grab them in. I could reach in and grab 3 at a time. Or whatever. Like if I grab my putter, driver, and my 9-iron, doesn't matter if I grab them in a different order, I still end up with the same 3 clubs in the end. Okay, so you must use your combination notation. The grad class of 165 students needs 3 students to be class reps. How many different rep groups could be chosen? So I have 165. I need to pick 3 of them. So I always say 165, choose 3, gives me 735,130 different options for choosing my 3 committee members. Example number 3 says in the Lotto 649, you need to select a set of 6 digits from the numbers 1 to 49. How many different tickets could you purchase? So it doesn't matter what order you scratch your numbers off in, you just need your 6 numbers in the end. So I have 49 numbers and I need to choose 6 of them. So there are actually 13,983,816 different combinations. So I guess if, how much is a ticket? I think if a ticket is worth like $2 maybe. So I guess if the jackpot was over $28 million, it would be worth your while to spend the money to buy every single combination so that you'd win. All right, example number 4. If you're playing a 2-man crib, you get dealt 6 cards. Okay, so we're getting dealt 6 from a standard deck of 52. Again, it doesn't matter what order those cards come to you in because you're going to rearrange them once they get in your hand anyway. So I have 52 cards. I want to choose 6. So there are 20,358,520 different hands that I could get in crib. That's kind of crazy. All right. In how many ways can a set of 4 students be chosen from a set of 10 students if there are no restrictions? Okay, so in other words, I just have 10 students and I want to choose 4 of them. There are 210 ways for that to happen. If Shannon must be included, so what that means is that, if I have so Shannon's going to be there, so that's going to be like 1 person, and then I need to choose 3 more people, but now I only have 9 to choose from. So that's going to be 84. If Shannon must be excluded, that means that I need to choose 4 people, but I only have 9 of them to pick from because Shannon can't be there. So that'd be 126. If Shannon must be included and Derek must be excluded, so that means I'm going to pick Shannon, that's going to be her, and I'm going to multiply that by the choices for the rest of the people. So now I need to choose 3 people, but I only have 8 to choose from because Shannon's already there and Derek cannot be there. So that comes to be 56. All right, so now we're going to look at combinations coming from more than one set. So there's 12 boys and 8 girls in the math club. So 12 boys, 8 girls. In how many ways can a committee of 3 boys and 2 girls be chosen? Okay, so what I want is I want 3 boys and 2 girls. Okay, so remember back to our unit on set 3, the word and means to multiply. And remember the word or means to add if we ever come across that one, right? So if I want to choose 3 boys, so I have 12 and I want to choose 3 of them, times by 2 girls, so I have 8 girls and I want to pick 2 of them. So, I mean, if I show my work, that comes out to be 220 times 28, which is 6,160 people, but you can feel free to go directly from that notation, punch it into your calculator and get your answer. And how many different 10 card hands can be dealt that contains 3 hearts, 4 clubs, 2 diamonds, and 1 spade? Okay, so basically you're getting from each of the suits. So there are 13 hearts. So I had 13, I want to choose 4 of them. And I want to get 4 clubs. And I want to get 2 diamonds. And I want to get 1 spade. Okay, so if I plunk all that into my calculator, I get 207,352,860. How many different 10 card hands can be dealt from a standard deck that contains exactly 2 aces and 3 queens? Okay, so this is a 10 card hand. I need to be a little bit careful here. And I'm going to get 2 aces and 3 queens. So I want to get 2 aces and I want 3 queens, but that only adds up to 5 cards. So then I need and 5 other cards, right? They could be aces or they could be queens. Oh no, exactly. So I can only have 2 aces and 3 queens. So just think about how can I pick my aces? Well, there are 4 aces in the deck and I want 2 of them, and it means to multiply. Queens, there are 4 queens and I want 3 of them. And I need to choose 5 other cards. So I got to think about how many cards are left. So remember, there's 52 in the deck. I have to take away all the aces because I can't have any more aces and I can't have any more queens. So 52 take away 8 leaves me with 44 cards. Okay, and when I punch all that in my calculator, I get 26,064,192. All right, last example here. If 2 letters are chosen from the word who and 3 letters are chosen from the word cares, how many 5-letter arrangements can be made? So this one's a little bit different because I know that when I arrange my letters, it matters, like they're different if I change up the order of my letters. So what we have to do is we have to make 3 decisions. Number 1, we have to choose our letters from the word who. Number 2, our letters from the word cares, and then arrange them. Okay, so if I want to choose 2 letters from who, so from those 3 letters, I want to pick 2 of them. And then, using the fundamental counting principle here, picking 3 letters from the word cares, so 5C3. And then I need to arrange those letters. So then think of it as my 5-letter arrangement. Once I have those 5 letters, it's going to be 5 times 4 times 3 times 2 times 1, or you could have just written 5 factorial there. So 3C2 times 5C3 times 5 factorial is going to give me 360, right? So this is picking the letters, and then we're arranging them. So this is kind of the culminating question. It's kind of a combination of a combination and a permutation. All right, so there are tons of practice questions for you to do there. Once you're done that, you can move on to the next lesson, which is just mixed practice, kind of putting it all together.